This is my best guess paper for paper 3 Edexcel now that we've seen paper 1 and 2. As always, nobody can guarantee what is definitely going to come up, but we can have a guess based on common topics that we usually see that we haven't yet seen. So I've put this paper together based on those. I hope you enjoy it and I hope you find it helpful revision. Question number 1, and I had to stay loyal to Polly the shark. Here we go. The frequency table gives information about the length of 45 small sharks. On the grid, draw a frequency polygon. So the reason I call this Polly the shark is because it looks a little bit like a shark fin most of the time. So it's just a silly way to remind you to not draw bars, but to kind of draw this dot to dot shape where we are joining up the frequencies. Now, Polly the shark, she lives in the middle of the ocean. So we're going to go between 0 and 5, the middle of the category, and go up to a frequency of 3. Be really careful with the y-axis here. I'm going up in 2s for every one. So 1, 2, 3, there, across to 7.5 and up to 9, across to 12.5 and up to 12, across to 17.5 and up to 15, and then across to 22.5 and up to 6. And then we join each of those sections up with a nice straight line, dot to dot. Don't join the first one to the last one, and don't join them to the origin. That is it, completed, 2 marks, all done. Okay, question number 2. Laura runs for 25 minutes at an average speed of 12 kilometers an hour. Tammy runs for 40 minutes. At what speed would Tammy need to run to complete the exact same distance as Laura? So I'm going to start by drawing my speed, distance, time triangle. Speed, distance, time. And we'd like to know first how far Laura has run. That's going to be the first thing we want to work out, the distance. So covering up that D, we'll do the multiplication that is left behind. What's left behind is next to each other, so it's S multiplied by T. So the speed, which is 12, multiplied by the time. Now here, our time is in minutes, but the speed is in kilometers per hour. So what I want to do is actually change this to be into hours. And to do that, I'm going to write it as 25 out of 60. That is now a fraction of an hour. So 12 times 25 over 60 is going to put that distance in kilometers for me. And that is 5. When we type it in our calculator, we get 5 there. Okay, so 5 kilometers is how far Laura runs. Now, Tammy is running for 40 minutes and we want her to cover the exact same distance. So we also want her to run 5 kilometers, but she's doing it in 40 minutes. So now, this time, we're covering up the speed. And what we're left with then is distance divided by time. So for Tammy, we're doing the distance, 5, divided by the time. Now again, I'd rather that time was in hours. And we've got 40 minutes, so I'm going to write it as 40 out of 60. And 5 divided by 40 over 60 is 7.5. So 7.5 kilometers per hour is the speed that Tammy would need to run at in order to match Laura's distance. Question number 3, and we have a universal set. So this funny squiggly E, that means your universal set. I like to think of it as my universe. It's everything we know about in the world right now. That is your universe. And all of those numbers, 1 to 16, we can see that that funny squiggly E is there as well. And that means that all those numbers need to go somewhere inside that rectangle. So let's start by thinking about what numbers are in A. We've got them listed there. And also what numbers are in B. So square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. So those 4 numbers need to be within the B circle, and 1, 3, 7, 9, 15 need to be within our A circle. First, we're going to check the intersection, any values that are in both A and B, and we can see that both 1 and 9 are within set A and also within set B. I'm left with 4 and 16 out here, and I'm left with 3, 7, and 15 out here. Now, a lot of students stop at that point, and we need to make sure that our universe is complete. So any numbers that we haven't yet put inside the rectangle now need to go on the outside. So I've got 1, I need 2, I've got 3, I've got 4, 5 would go there, 6 would go there, 7 we've got, 8 would go there, 9 we've got, and then 10, 11, 12, 13, and 14. So all those numbers are going on the outside, and we now have all 16 numbers somewhere inside that rectangle. So we've completed the Venn diagram. A number is chosen at random from the universal set. Find the probability that the number is in the set A union B. A union B. So for A union B, I'm looking, let me draw my two little pictures for you. If you have the union, I want you to think of it like a bucket. It's going to scoop all of the numbers from A or B into it. So any numbers from A or B can be scooped into it. So in this case, I'm looking for numbers inside both of them. So I've got the, let me highlight it, 3, the 7, the 15, the 1, the 9, the 4, and the 16. The probability of me picking one of those numbers is 1, 2, 3, 4, 5, 6, 7 out of the 16 numbers that there are altogether. If you'd been asked for this one, the intersection, that's the bit that is crossing over, that is overlapping there. The probability of selecting one of those numbers would be 2 out of 16 because there are two numbers in the intersection. You don't need to simplify your answer, that would be all good. Well, we can't simplify for 7 over 16 anyway, but if it was 2 over 16, you wouldn't need to simplify your answer with probability. Question number 4, Manon invests £3,000 in a savings account for 5 years. The savings account pays compound interest at a rate of 2.4% per annum. Calculate the total amount of interest Manon will have after 5 years. Now, 2.4% per annum is another way of saying per year, but the wording of that sometimes throws you all off, so I thought I'd include that one. Right, we're going to start with £3,000 and we're going to multiply it by, now you want 100% of the money and an extra 2.4%. And when we want that, that means in total we want 102.4%. But if I multiply 3,000 by 102.4, this is going to be massive. So what I want to do is change that to a decimal multiplier. And to do that, we're going to divide by 100 to go from percentage to decimal. So 1.024. 3,000 times 1.024, and then we raise that to the power of the number of years. So 3,000 times 1.024 to the power of 5 gives me £3,377, and then it's 0.6997. And with money, what we want to do is make sure we round it to 2 decimal places. However, this 9 rounds up, so it's going to become 70. So this is £3,377 and 70 pence. However, this question did not say how much money does she have in the bank. It says calculate the total amount of interest. So for our final answer here, for full marks, we did need to then take the 3,000 away. And that leaves us with £377 and 70 pence there. Question number 5. Austin is planning a holiday to Thailand for 10 nights. The flights will cost £685 for a return journey. The hotel costs 900 Thai baht per night. The exchange rate is £1 is 40.92 Thai baht. Calculate the total cost of the flight and the hotel. Give your answer in pounds. So we already have the return journey in pounds. What we want to now work out is the cost of the hotel. Now the hotel costs 900 per night, 900 TB per night. And we know that Austin is staying for 10 nights. So we're going to multiply that by 10, which is 9,000 Thai baht. Now, to get that into pounds, we need to look at the exchange rate. And we know that £1 is equal to 40.92 TB. If we were going from pounds to Thai baht, we would multiply by 40.92. But because we're going the other way, we're actually going to divide by 40.92. So I'm going to take my 9,000 and divide it by 40.92 in order to get that into pounds. Now, you could have done that per night and then multiplied it by 10. Wouldn't have made any difference to your answer. So 9,000 divided by 40.92 is 200, and this is now in pounds, £219, and let's round it to 2 decimal places because it is money, 94 pence. Let's now add on the flights, so £685 for the flights, and that gives me a final answer of £904 and 94 pence going on the answer line there. It's a nice number. Right, question number 6. A number h is written correct to 2 significant figures. The result is 4.2. Complete the error interval for x. So this has been rounded to 2 significant figures, and the second significant figure is in the tenths column. So this is the same as rounding to the nearest 0.1. In this case, that second significant figure is the tenths column, so 0.1. Now, we half that amount. If we've rounded to the nearest 10, we go 5 above, 5 below. If we've rounded to the nearest 100, we go 50 above, 50 below. If we round to the nearest 5, we go 2.5 above, 2.5 below. Here we've rounded to the nearest 0.1, so I'm going to go 0.05 above, so 4.25, and 0.05 below, so 4.15. And some of you might be thinking, well, hang on, 4.25, that would round up. And that's why there's no equal to on the inequality at the top end. We can go so infinitely close to it, we can go to 4.249 recurring, that we basically just call it 4.25 and say we can go up to that value. So that would be that. One thing I will say, if it was truncated to 4.2, that just means it's chopped off. So they don't pay any attention to the next number. And if the question had told you that it'd been truncated to 4.2, we would go 4.2 up to 4.3, because the next number could be a 0 or it could be 9 recurring. So for truncated, it would be that. For rounded, it would be that. Question number 7, an exam is out of 80 marks. 40% of the paper covers geometry and statistics. The rest of the marks in the paper cover number, algebra, and ratio in the ratio 6 to 5 to 5. How many marks were allocated to number? So let's start by doing 40% of 80, and that is 32. So we know 32 marks are going to geometry and statistics, and the rest of the marks, 48, because I'm doing 80, take away 32 to get 48. The rest of the marks, 48, need to be shared in this ratio. So 6 to 5 to 5, and we could draw them out. 1, 2, 3, 4, 5, 6, to 1, 2, 3, 4, 5, to 1, 2, 3, 4, 5. And this is number, this is algebra, and this is ratio. I need to take my 48 marks and share them equally over all 16 piles. 48 divided by 16 is 3. So this is 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. I should have picked a smaller number, shouldn't I? 3, 3, 3, 3, 3. So the number of marks for number is 6 lots of 3, so 18. The number of marks for algebra is 5 lots of 3, so 15. And then for ratio, also 15. So 18 marks was our answer there. That was the number of marks allocated to number. Question number 8. It takes 3 builders 12 days to build a wall. How many days would it take 4 builders to build the same wall? The first thing I'm going to do is write down 3 builders equals 12 days. And always with these proportion questions, we need to think about 1. So what if we only had 1 builder? And the instinct here is to say, well, 1 builder, I've divided the number of builders by 3, let's divide the number of days by 3. But we need to think with real common sense on these questions. If you've got less people building that wall, it's not going to take less time. It's going to take more time. So if I've divided the number of builders by 3, I actually need to multiply the time by 3, and that would be 36 days. Now I'd like to consider, okay, what if I have 4 builders? And now if I've multiplied the number of builders by 4, it's going to take 4 times less time. So dividing by 4 means this would take 9 days. So 9 days is my answer there. And then it says, state one assumption you made in working out your answer to part A. And always with this, with proportion, we want to say that the rate is the same. We've assumed that all of the builders work at the same rate, when actually one of them might be a little bit lazy. So we have assumed they all work at the same rate. And that word rate is really important there. Question number 9, and we're making x the subject of t equals 3 bracket x add 7, all divided by x minus 1. So we're going to start by getting the x's on one side of the equation and everything without an x on the other. And to do that, we're going to multiply by x minus 1 to get rid of that fraction. If I multiply one side by x minus 1, I need to multiply the other side. Remember that equals shows the middle of your equation. So multiplying the right-hand side by x minus 1 gets rid of that denominator, and we're left with 3 lots of x add 7, just the numerator. And then on the right-hand side, we've got t lots of x minus 1 because we've multiplied that side too. Now let's expand out all the brackets. So I've got tx minus t equals 3x add 21. And we want everything with an x, because that's what we're making the subject, to be on one side, and everything without an x to be on the other side. So I'm going to add t to get that over here. And I'm also going to take away 3x to bring that one over here. So tx minus 3x equals 21 add t, or t add 21, whichever way around you wrote it. Now, in order to get those x's together, they are not like terms. The only way to bring them together is to factorise. So I'm going to take an x outside a bracket, put t minus 3 inside the bracket, and then I'm going to switch that around. I don't know why, I just don't like it that way around. And then divide by the bracket. So x equals t add 21, all divided by t minus 3. And that would be your answer there. It doesn't matter which way around you put them, as long as the signs are the same. So there we go. X equals t add 21, all divided by t minus 3. Question number 10, and we have vectors. I know you all missed it on paper 2. The diagram shows trapezium OANB. O to A is 3A, A to N is B, and O to B is 4 lots of A to N. So I'm going to put there that that is 4B, because I know it's 4 lots of A to N, so 4 lots of B. It says N to P, so 5 parts there, N to P, P to B is in the ratio 5 to 4. So I'm going to straight away make that 5/9 and 4/9, because that's what fraction of the line we have on each part. Okay, now we've got to find O to P. In order to get from O to P, I either need to go up here, across here and down, or I need to go along the bottom and back up. But either way, it's using the vector N to B, which at the minute I don't have. So this is what we're going to start by working out, N to B. And we can get that by going all the way round. So N to B, I'm going to go back here, down here, and along here. Now remember, if you're going with an arrow, you're adding it. If you're going against an arrow, you're taking it away. So I've got minus B going on this bit, and then minus 3A, and then add 4B, which overall, minus 3A, add 3B. Great, so that's N to B. Now N to P, we said, is just 5/9 of that. So 5/9 of minus 3A, add 3B. We can multiply that fraction in, so N to P is, now if I've got minus 3 multiplied by 5, remember when you're multiplying a fraction, you're just timesing the top. So minus 15 over 9A, add 15 over 9B. And since they're both in the 3 times table, let's simplify that to 5 over 3. So 5 over 3A, add 5 over 3B. Now, we were asked to get from O to P. And in order to do that, I'm actually going to go up and round. Now, the reason I'm going to go up and round is that we just worked out this direction. So I just feel like it's easier if I go up here, across here, and down here. You can go along here and up, but you're going to need to reverse the signs of that vector, and I'd just rather go the first way, just because I think it just makes more sense in my head. So we're going to go O to P is 3A, add B, minus 5/3 A, add 5/3 B. And now we just need to simplify that. So 3 take away 5/3 leaves me with 4/3 A, and 1 whole B, add 5/3 of B. 1 add 5/3 is 8/3. So add 8/3 B. That would be my answer. You could, if you wanted to, bring the third outside. So you could say that's the same as 1/3, 4A, add 8B. You could even bring 2/3 outside, actually, couldn't you? And then have it as 2A, add 4B. But you're fine. Just leave it like this. 4/3 A, add 8/3 B. That is my final answer for O to P. Question number 11, Fido collects 40 sticks of different lengths. The cumulative frequency graph shows information about the lengths in centimetres of these sticks. Find an estimate for the percentage of sticks that are longer than 17 centimetres in length. Right, so we're going to 17, which is down here, 16, 17, and that is that line there. Read up to your graph with a nice straight line with a ruler and go across. And I get that to be 31. Now that means that 31 of the sticks were less than 17. And actually, if we want how many were longer than 17, we need to think about the sticks that are above here. And that's going to be 9. From 31 up to 40, that is 9 sticks. So the percentage is going to be 9 out of 40 times by 100 to get that as a percentage. So the fraction of sticks is 9 out of 40. 9 out of 40 multiplied by 100 gives me a percentage of 22.5%. Great. Question number 12, and we're asked to simplify this algebraic fraction. Now, the first thing we want to do whenever we see an algebraic fraction is check whether anything can be factorised. And I'm looking at this and I'm thinking, yeah, I've got a quadratic on the top and the bottom there. I can also see that this linear term can be factorised as well. So let's put all of this into brackets. Now, with this denominator, I need to think, I actually think that's one bracket. They've got something in common. And if they've got something in common, we can take that outside a bracket. So 2 bracket x squared minus 25. And you might think, yeah, okay, great. I factorised it. One thing came outside the bracket. I'm now looking at x squared minus 25 and I'm thinking, that is now the difference of 2 squares. So actually now we're going to make that denominator 2 lots of x minus 5, x plus 5. So that factorised further. Now the numerator, we know that's going to be 2 brackets. I've kind of done it twice now, sorry. It's going to be 3x and x. And multiplying to make 10, let's start by trying 5 and 2. It might be 1 times 10, it might be 2 times 5, but I'm going to start by trying 2 times 5. And actually, if you put the 5 over here, we get 15. And if you put the 2 here, we get 2. 15 and 2 is going to make minus 17 as long as they're both negative. And that works because minus 2 times minus 5 multiplies to make positive 10. So I'm happy with that. Now my numerator, I can divide by x minus 5, and my denominator, I can divide by x minus 5. Now we're dividing this by 1 over 4x add 20. And we know that dividing by a fraction is the same as multiplying by its reciprocal. So I'm actually then going to multiply this by 4x add 20 over 1. However, we said that 4x add 20 could be factorised. So that's 4 brackets x add 5. And now we can see that the x add 5 here can cancel with the x add 5 here. That works because we're multiplying. So we can treat this as one big numerator and one big denominator. And what does that leave us with? Well, we've got 3x minus 2 left over here. And I've actually got a 4 left here, but I've got a 2 left here. So 4 divided by 2 is 2. So that leaves us with 2 lots of 3x minus 2. And the denominator has just become 1. So instead of leaving this over 1, I'm just going to write it as 2 lots of 3x minus 2. You may have written that as 6x minus 4. Either of those would be absolutely fine for full marks there. Question number 13. Here are the first terms of a sequence. Find an expression in terms of n for the nth term of this sequence. Now we can see that the sequence has gone up by 3, then it's gone up by 7, and then it's gone up by 11, and then it's gone up by 15. So this is not going up by the same amount each time, so it's not an arithmetic sequence. And actually we can see that the second difference, the difference of the difference, is the same. And that tells us that this is a quadratic sequence. Whatever that second difference is, you're going to half it, and that gives you the coefficient, the number, in front of n squared. So I know this sequence needs 2n squared. If you think about the sequence 1n squared, or the sequence of square numbers, it goes 1, 4, 9, 16, 25, and so on. That's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. I want 2n squared, so I'm going to double each of those numbers. So 2, 8, 18, 32, and 50. I know that this forms part of the sequence that I need. And now we're just going to subtract it. So 0 take away 2 is minus 2. 3 take away 8 is minus 5. 10 take away 18 is minus 8. 21 take away 32 is minus 11. And 36 take away 50 is minus 14. And this is the other part of the nth term that we need. Now minus 2, minus 5, minus 8, minus 11, it's going down in threes. And this is a linear nth term. So to work this out, it's going to be minus 3n because we're going down in threes. But the minus 3 times table would start on minus 3. And our sequence, this sequence that we're trying to work out, is starting on minus 2. So that is 1 bigger. So minus 3n add 1 is the nth term of that bottom row. 2n squared is the nth term for the top row. And we know that if we add them together, we get the sequence at the top that we were looking for. So therefore our final answer here for the nth term is 2n squared add, so minus 3n add 1. They're just going together to make that nth term of the sequence. It then says find the 14th term of this sequence. So we're going to do 2 lots of 14 squared minus 3 lots of 14 add 1. If you would like a number in the sequence, all you do is change n to be the position. So 2 lots of 14 squared minus 3 lots of 14 add 1. And that gives me an answer of 351. Question number 14, the diagram shows a right-angled triangle. All the measurements are in centimetres. Show that x squared minus x minus 8 equals 0. And questions like this, the equation just feels like it kind of comes out of nowhere. And normally we need to use the information in the question to form an equation with the information that we're given. So if it said, for example, that the area of this triangle is 30, we would say, okay, base times height divided by 2 equals 30 using the information we've got. But we're really not given anything here except for the fact that this is a right-angled triangle and we're given all 3 sides, which is making Pythagoras alarm bells ring in my head. So what we are going to do here is set up an equation using the fact that we know that a squared add b squared equals c squared. So x add 4 squared. Now when we square an expression like that, we are multiplying it by itself. So x add 4 times x add 4, add x minus 1 times x minus 1 equals c squared, which is 2x add 1, that longest side over from the right angle. Now expanding this out, I get x squared, I've got 4x and 4x, so 8x add 16, add, this one's going to be x squared minus x, so minus 2x, add 1, and then here we've got 4x squared, add 2x, so add 4x, add 1. Simplifying that left-hand side, I've got 2x squared, add 6x, add 17, collecting my like terms, and then still on the right, 4x squared, add 4x, add 1. Let's now make one of these sides equal 0 as per the equation that we've got, and if we wanted to solve it, we would do that anyway. I'm going to subtract 2x squared from both sides. So that leaves me with 2x squared. I'm then going to take 6x away from both sides. That leaves me with minus 2x. And then I'm going to take 17 away from both sides. And that leaves me with minus 16. Now we're almost there. It's looking very similar to the equation that I'm supposed to get, except for the fact that everything I've got is 2 times bigger. So I'm going to divide both sides of this equation by 2. So 0 equals x squared minus x minus 8. And we've got what they were looking for. Now for part B, we are asked to find the value of x and give our answer to 2 decimal places. We have a quadratic, and even if you weren't able to do part A, they told you what the equation was going to be, so you could have done part B regardless. Now we're going to use the quadratic formula here because factorising wouldn't give us answers where we would have to round to 2 decimal places, so I'm assuming it doesn't factorise. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And a is the coefficient of x squared, which in this case is 1. You could put 1 there, it would be the same. B is minus 1, we can see from there, and c is minus 8. Putting those values in, I've got minus minus 1 plus or minus the square root. Now be really careful when you're squaring a negative. You can put -1 squared in brackets like that. That will do it correct in your calculator. Or you could just put 1. But if you put -1 squared with no bracket, it's going to tell you it's -1 rather than 1. So -4 times 1 times -8 all over 2 times a, 2 times 1. Let's now pop that in our calculator, and that tells me that x is 3.37228, so rounding to 2 decimal places is 3.37 for the first solution. And for the second solution, we're going back and we're changing the plus to be a minus where it's plus minus. So we've got a minus for that second solution, and that is x equals -2.37, which we can disregard. This is a physical shape, so we need to make sure that the lengths are positive, and that's going to happen when x is 3.37, so that is your answer there. Question number 15, the line L1 goes through the points -3, 5 and 1, 4. The line L2 is perpendicular to line 1 and goes through the point 8, -2. Find the equation of the line L2. So the line L1 goes through these 2 points, and what we need to do is find the gradient first between those points. And to find the gradient, we're going to do rise over run, or change in y divided by change in x. So y1 minus y2 over x1 minus x2. So I'm going to do the y coordinate, take away the other y coordinate, over the x coordinate, take away the other x coordinate. And we need to make sure we go the same way each time. So that's -1 on the numerator, and 1 minus -3 is 4. We're adding that on. So -1/4 is the gradient of line 1. We want to go perpendicular to that. And to do that, we do the negative reciprocal. So if line 1 has a gradient of -1/4, then line 2, if we do the reciprocal of 1/4, we get 4, and it's going to be positive. So I know it's y equals mx plus c for the equation of line 2, and the gradient we now know is 4. So y equals 4x add c. Now we can use the point up here to help us, 8 minus 2. So x is 8 and y is -2. This point lies on the line L2, so we can use that to help us. I'm going to change y to be -2, and I'm going to change x to be 8. So 4 times 8 add c. -2 is 32 add c. And if we take 32 away from both sides, we get c to equal -34. So the equation of the line is y equals 4x -34. Question number 16, the diagram shows a prism. Calculate the volume of the prism, state the units with your answer. So in order to get the volume of a prism, we need to do the area of the cross-section multiplied by how far back it goes. And here we have a triangle where we cannot do base times height, but I do know this side, and I do know this side, because it's going to be 16, the same as at the back of the prism. And I do have the angle in between. So actually what we can do here is get the area of the triangle using half AB sine C. We have 2 sides and the angle in between. So I'm going to do half times 14 times 16 times sine 47. And that is 81.9116. Now, in order to turn that into the volume, we need to multiply that by how far back it goes. So 81.9116 multiplied by 18, times that answer by 18, and we get a volume of 1,474.409. I'm just going to round it to 1 decimal place because I forgot to tell you guys what to round it to. So I'm going to do 1,474.4 centimeters cubed would be the units for the volume of that prism. Question number 17. I've got t equals a minus 2b, all divided by b squared, where a is 42.1, correct to 1 decimal place, and b is 7.52, correct to 2 decimal places. It says by considering bounds, work out the value of t to a suitable degree of accuracy and give a reason for your answer. So in order to do this, we need to get the upper and lower bound for each. And we want to work out the absolute biggest and the absolute smallest, and then we can consider them both when we work out our answer. So for A, it's been rounded to 1 decimal place, therefore it's been rounded to the nearest 0.1. So we're going to go 0.05 above and 0.05 below. Same for B, but it's been rounded to 2 decimal places, so 7.525, and 7.515 if we go 0.005 above and 0.005 below. Now, by considering bounds, so let's do t upper here, and let's do t lower here. So for the upper bound, I'm doing a minus 2b on the top, and that needs to be as big as it possibly can be. So I'm going to use the biggest a I can, which is 42.15, but I'm going to take away 2 lots of the smallest b I can to keep that numerator as big as possible. And we're going to divide that. Again, we want to divide that by as little as possible to keep this answer as big as we can. So I'm going to divide it by 7.515 squared. We have to square it because that's what's in the formula. So that's my first one. Same for the other one, but we're going to use all the opposite values. I'm going to do the smallest value of a, so 42.05 minus 2 lots of the biggest b, 7.525. all divided by b squared, 7.525. We want the biggest value of b on the bottom being squared. Let's work out each of those then. Okay, those are both of the answers for each of my bounds, my upper bound and my lower bound. And now we need to decide a suitable degree of accuracy. And to do that, we're going to see how many significant figures they agree to before they stop being the same. So if you rounded them both to one significant figure, they would both be 0.5. If you rounded them both to 2 significant figures, they would both be 0.48. 3 significant figures and we get 0.480 and 0.477. So then they go different. So we're going to say 0.48 because both bounds agree to 2 significant figures. So t equals that, because both bounds agree to 2 significant figures. Okay, question number 18, and we have transformations of functions. The graph of y equals f of x is shown on the grid below. On the grid above, sketch the graph of y equals minus f of x. Now, we need to remember that anything inside the bracket is going to affect the x direction, and anything outside the bracket is going to affect the y direction. We know that a minus is a reflection. If it was f of minus x, your reflection would be happening in the x direction over the y-axis. But because this is outside, minus f of x, my mirror line is going to be the x-axis, and this is going to reflect in the y direction. So this point here is going to become this point here. This point here is going up here, and this point here is going up here. And we're going to end up with going through the same values there on that axis. Your sketch should look like that. Hopefully a little bit neater than mine. Okay, let's go. Question number 19. Show algebraically that the straight line with equation y equals 2x minus 1 is a tangent to the curve y equals x squared. Now, if we're talking about a tangent, or if we're talking about one line crossing a quadratic or crossing a curve, this is simultaneous equations. So I'm going to write y equals 2x minus 1 and y equals x squared. But because we're looking at when they cross or when they intersect, or in this case, it being a tangent, we're going to make them equal each other. We're going to substitute it in. If y equals 2x minus 1 and y also equals x squared, then x squared can equal 2x minus 1 at the points of intersection. And to solve this, again, this is a quadratic, so we're going to make it equal 0, take away 2x from both sides and add 1, and you should be left with this. Now, how are we going to show that it's a tangent? If a line goes through a quadratic, you will end up with 2 different solutions. If it doesn't cross the quadratic, you will end up with no solutions and we won't be able to solve it. If it's a tangent, it's just going to touch and carry on. And in that situation, there will only be one solution. And actually, if you notice, this factorizes to be x minus 1, and x equals 1 in both cases. So there is only one solution. The only solution is when x equals 1. And we can substitute that back in. If x is 1, 2 lots of 1 is 2, take away 1, the y coordinate is 1 as well. So 1, 1 is the only point of intersection, and therefore it has to be a tangent to the curve. Question number 20, and we are completing the square. We are finding the coordinates of the turning point. You'll also know if it's completing the square if they ask you to give it in this format, something like that. Maybe with a number out the front, so maybe that'll be A, maybe that'll be B, maybe that'll be C, either or if they ask you for the turning point, we know that that is completing the square. Now, we can't complete the square with the 3 here. It has to just be x squared. So the first thing I'm going to do here is factorise that out. And that leaves me with x squared add 4x. Now, that's not completing the square. I'm just factorising the first 2 terms in order to be left with x squared so that we can complete the square here. Now, to complete the square, we half this number and we put that in a bracket. So x add 2, we square that bracket and we take away this number squared, so minus 4. That is still what's making up the inside of that square bracket. It's still being multiplied by 3 and we're still taking away 20. Let's now bring that 3 back in to both parts. 3 lots of x add 2 squared minus 12, because it's 3 lots of the 4 as well, minus 20. So I've got 3 lots of x add 2 squared minus 32. Now, in order to calculate the turning point from that, we'd like to know what value of x would make the bracket equal 0, which is going to be minus 2. And then what is the constant term over here, minus 32 there. That is your turning point. Question number 21. The diagram shows a sector with radius x and arc length y. The ratio x to y can be written in the form k to pi. Find the value of k. So y is the arc length. Let's think about how we would work out the arc length. The circumference of a circle is pi times diameter, but I don't want the whole circumference here. I want to get y, and to get y, we would do pi times the diameter, but we would multiply it by 60 out of 360 because I only want that fraction of the circumference. Now the diameter is going to be 2x because x is the radius that goes to the middle of the circle. The diameter goes all the way across. So let's try this again over here. Y equals pi times 2x, that's my diameter. And instead of timesing by 60 out of 360, I recognise that that's a sixth. So I'm going to divide that by 6. Let's now sort that out a bit. 6y equals 2 pi x if I'm multiplying up by 6. Okay, if 6y equals 2 pi x, we can also divide both sides by 2 there. So 3y equals pi x. Now, if you want to go, actually I'm going to write it the other way around just for ease here because I want to go x to y. So pi x equals 3y. If you want to go from an equation to a ratio, they switch. And let me show you why. Let me go 5x equals y. Can you think of 2 numbers that would satisfy that equation? Let's keep it nice and simple. If x was 1, y would need to be 5. And so the ratio x to y would be 1 to 5 because any value of x is being multiplied by 5 in order to get y. So actually, if the equation is one way, the ratio, you can switch it. There's other ways of doing it, but that's how it works best in my head. So I'm going to say if pi x equals 3y, then the ratio of x to y is 3 to pi. And so the value of k that we were looking for here was 3. Question number 22. The shape below is made up of a cone and a hemisphere. X is the radius of the cone and the radius of the hemisphere. The total volume of the shape is 540 centimetres cubed. Calculate the value of x, give your answer to 3 significant figures. So we know that the volume of the cone add the volume of the hemisphere equals 540. So let's start by writing that. The cone is 1/3 times pi times x squared times 5x. That's using 5x as the height and the radius is x as well. Add. Now, for a hemisphere, instead of doing 4/3 pi r cubed and dividing it by 2 after, if it's a hemisphere, you can just make it 2/3 pi r cubed, and it just makes your life a little bit easier. That's half as big. So 2/3 times pi times the radius, so x cubed, and that equals 540. Great, simplifying that down a bit then, I've got a third pi 5x cubed, add 2/3 pi x cubed, which altogether equals 540. Now we can also say that that's just 5/3 pi, so actually let me sort that out. A third times 5 is 5/3 pi x cubed, add 2/3 pi x cubed, so altogether 7/3 pi x cubed equals 540. I'm then going to divide both sides by 7/3 pi, so x cubed is 540 divided by 7/3 pi, and then let's cube root that answer. So x cubed is 73.666, and then if we cube root that answer, we get 4.192. Three significant figures, so 4.19 is the value of x there. Calculate the value of x, 4.19. I'm happy that that makes sense. Fabulous. And last but not least, question number 23 is indeed circle theorems. Right, the points B, F, E and D lie on the circumference of a circle. ABC is a tangent, angle DBC is 63, and angle BFE is 102. The size of angle EBD, so this one, to the size of angle BEF, so this one, is in the ratio 3 to 2. So I can put 3x and 2x there if you wanted to. Okay, calculate the size of angle FBE. So this is the one we want to work out. Great, let's start then with the alternate segment theorem. I've got a triangle on its tip on the tangent, and that tells me that this angle here is the same as this angle here. So let's put 63 degrees up there. I can also see that I've got a cyclic quadrilateral. All four corners of this quadrilateral are touching the edge of the circle, the circumference of a circle, and therefore if this angle here is 102, I know that this one is 78 because opposite angles in a cyclic quadrilateral add up to 180. Now I'm going to look at this green triangle. If we add together 63 and 78, I get 141, and 180 take away 141 is 39, which is going to go here. That is my missing angle there. Now we were told that this angle to this angle is in the ratio 3 to 2. So in order to find the angle up here, I'm going to divide that by 3, which is 13, and multiply it by 2, so 26. So this angle here is 26. There we go. Now I can go ahead and look at this triangle. Again, angles in a triangle add up to 180. So 102 add 26 is 128. 180 minus 128 is going to be 52 degrees. So 52 degrees was your final answer for that one. And that was the end of my paper. I very much hope you enjoyed it. Hopefully it gave you a steer on what to revise. Thank you so much for all of the lovely comments. I'm really glad that you found my papers and stuff helpful. Thank you so much for being here. I really, really hope paper 3 goes well for you.